Hi, this is Mr. Mac. Today, we're going to talk about quadratic functions. Now, the quadratic function, y is equal to x squared, was one of our parent functions, and we learned some things about transformations and so forth with the quadratic function. And if you'll recall, the quadratic function, the basic graph of the quadratic function was a parabola. And we learned how to translate it left, right, up, down, and stretch it vertically and reflect it over the x-axis. Now, we're going to look at the quadratic function in more detail in this particular video. So, first of all, the general form for the quadratic function is f of x equals ax squared plus bx plus c. Now, a represents the coefficient of x squared, b represents the coefficient of x, and c represents the constant. An example of a quadratic function might be f of x equals 3x squared minus 5x plus 2. Now, in this particular example, a is 3, b is negative 5, and c is 2. Now, we call a the quadratic coefficient, or we call a the coefficient of the quadratic term. We call b the coefficient of the linear term, and we call c the constant. Now, we learned in translating quadratic functions that y equals a times the quantity x minus h squared plus k were all the translations we could do with the quadratic function, where the vertex was at the point hk and the axis of symmetry was the line x equals h. Now, with general form, the quadratic function is still going to have all of those same characteristics, but the question is, how will we find the x value of the vertex, the axis of symmetry, and the vertex if we're given a quadratic function in general form? Well, there is a simple equation that relates all of those things together, and it works like this. If you have y equals ax squared plus bx plus c, then it can be transformed into y equals a times quantity x minus h squared plus k in the following way. H, see, if we have this equation, we can find h by saying h is going to be equal to negative b over 2a, and then k is going to be f of h. In other words, once you know what the x value of the vertex is, that's what h is, you take that value and you put it in for x in the quadratic polynomial, and the value you get out is k, the y value of the vertex. Now, also, the axis of symmetry is still going to be x equals h, the vertical line that passes through the vertex. Now, if you're asked to graph a quadratic function in ax squared plus bx plus c form, the method is going to be something like this. First of all, let's go to a new page here. To graph f of x equals ax squared plus bx plus c. First, find the x coordinate of the vertex. Second, make a chart choosing the x found in number 1 and instead of first here, I guess we need a 1 so that makes sense. Make a chart choosing the x value found in number 1 and maybe 2 other values on each side of that x. 3, plot those points. And 4, connect them with a smooth curve. Now, in the solution videos, there are lots of examples of that, so I'm going to just leave you to watching the solution videos to see that done, and it'll be done over and over and over again. Now, once again here, let me just make sure. The x-coordinate of the vertex is going to be negative b over 2a. That equation is going to be very, very important to you. Now, one of the things that we did learn from the quadratic function and so forth is that the vertical stretch a, and the vertical stretch a is going to be the same a, in other words, in f of x equals a times x minus h squared plus k. This a right here is going to be the very same a as that a right there. If a is positive, the parabola opens up. If a is negative, the parabola opens down. If a is 0, there is no parabola, so a has to be either positive or negative for there to be a parabola. Now, notice if a parabola opens up, then the vertex is the lowest value. So hk is going to be the lowest point on the graph of the parabola. Now, you need to be careful or to delineate some things here. First of all, h, the x value of the vertex, is the answer to the question, at what value does the function have a minimum? When a question is asked like that, in other words, what would you do to get a minimum? What would you put in to get a minimum? At what value does the function have a minimum? Those questions all are asking for the x value of the vertex. Now, k is the answer to the question, what is the minimum value of the function? Now, if you just look at these questions superficially, they can seem to be the same question, but they're not. They ask for two specifically different things, and it is very important that you delineate between these two things in the questions that are asked. The x value is what you put into the function to get a minimum. The y value of the vertex is the minimum you get. And those are two different questions. Now, that's when a is positive. Now, if a is negative, a less than 0, if a is negative, your parabola is going to open downward. Notice then that the vertex, the point hk, is the highest the function will go. And here, the question, the green question would be, for h, at what value does the function have a maximum? And the red question here would be, what is the maximum value of the function? And that would be k. So you need to be careful and make sure that you're answering the question that's asked. One more thing that we need to talk about here. When you have a parabola or a quadratic function, there will be a vertex someplace, and then the quadratic function will either open up or down. We'll show you one here that's opening up. In fact, I don't know if this is a good enough drawing here. There, that's better. Now, notice there is symmetry with respect to the axis of symmetry, the dotted line. Now, somewhere over here, this quadratic function crosses the y-axis. Now, if we were to go to the axis of symmetry and then the same distance on the other side, we would get what is referred to as the symmetric point. Now, it's very easy to find the y-intercept of a quadratic function. If you have f of x is equal to ax squared plus bx plus c, remember the y-intercept is what you get when you put 0 in for x. And notice, if you put 0 in for x, ax squared is 0, bx is 0, so you just get c. So the y-intercept is going to be the point c, or actually 0c. Now, if the axis of symmetry is, let's say, x equals 2, then 4 units to the right, you will also be at the height of c. So we'll also have 4c as the symmetric point. So an easy point to find is, once you know the y-intercept, you can go to the axis of symmetry and then go the same distance beyond that, and that will be another point on the graph. If you just want a quick sketch of the parabola, if you can find the vertex and the y-intercept and the symmetric point, that gives you 3 points, and you can make a quick sketch of the parabola. If you want to be more accurate, probably need more points than that, but a lot of times it would just say sketch the parabola, and that would be enough. Now, it is very, very important that you watch the solution videos, because a lot of this is explained again and again and again as we do the problems. It is important that you go through and take a look at the solutions and make sure you understand how these things connect together, and then you'll be able to do these problems and there won't be any trouble. So good luck with that. And we're done.